So hi, I'm Tero. I wanted to kick us off tonight by talking a little bit about components, because we're going to have a talk about Angular 2 later, and components are very much a part of that. But what I want to focus on is really applications written in Angular 1 that we are maintaining, most of us at the moment, that are not component applications, and how we might be able to transform them into something that's closer to what Angular 2 is all about. So first of all, what I mean by components, I think the best definition I've heard was from Brian Ford from the Angular team. Earlier this year in Texas.js, he was talking about the fact that most of the major JavaScript frameworks are now converging into this style where the component is the main primitive from which you build UIs. And by component, he meant these atomic pieces of user interface from which you compose your application that you can reuse and combine at will. And Angular 2 will very much be all about components. And I think we're going to see a lot of that later tonight, but I'll just briefly mention this, that in Angular 2, you write your application UIs from components, which are these elements that have their own inputs and outputs, and which you combine by using them in your templates. And the way you create components in Angular 2 is by writing some TypeScript or ES6 code. And again, I won't go into the details of how the Angular 2 components work, because I don't need to, because we have Andreas here. But what I will mention is that there are really, I think, three key pieces to every component in Angular 2, which are the interface boundary, where you define what are the inputs of each component and what are the outputs, so the properties and events that go in and out of that component. And then we have the UI template, which we define in HTML, and then we have some code, some logic that goes behind that UI, which actually defines how that component behaves. So I think every component kind of has these three logical parts that together form what that component is. And I think it's actually the case that in Angular 1, we have everything we need to pretty well approximate these components, because we have directives and we can use directives. So we can define these element directives and then have bindings to them using these attributes and do something very, very similar to what Angular 2 does. And of course, the way we define them is completely different from Angular 2. I don't think there's like a single thing that's exactly the same here as in the Angular 2 example, but the logical parts are the same. So we have an interface boundary defined by this scope and controller bindings. And we have a UI template defined in HTML. And we have the code that goes behind the template defined in the controller. So these parts are all the same as in Angular 2, even though all the APIs are different. And I think if you construct Angular 1 applications in this way, it isn't probably that hard to take them later to Angular 2, even though you have to change most of the code. Architecturally, you are already kind of aligned with Angular 2. And that's like the biggest change you have to make usually when making such an upgrade. And I should probably clarify that I'm not necessarily talking about putting this stuff into the same file. That's not important. And what I actually do myself usually is separate these things into different files. So there's a directive file, controller file, template file. But what is important that those pieces are there and they go together by the way you organize these things, and they form this together. They form this component. So you can go to Angular 2 quite easily, maybe, if you write your code in this way. But the problem is that, and what I want to really talk about tonight, is that most of the code we have isn't like this. Like, we have Angular 1 applications that have existed for years, and this didn't become a popular pattern until very recently. I don't think it's still like the mainstream, because it's not the way Angular is taught. Instead, we have this alternative architecture in Angular 1, which is often called scope soup, which I think pretty well explains what it's all about. And this is how I learned to write Angular, and I think it's the case for most people. because it used to be how it was done. And it's characterized by a few things, which are that there's a lot of ng controller and ng include used in these applications. And it's also the case that the controllers and the templates usually don't go in pairs. So you may have large controllers that are managing many templates, and you have large templates that have many controllers in them. So it's hard to find stuff because these things don't go in controller template pairs as they do in components. And it's also the case that the sharing of data in these applications happens usually through scope inheritance. So you put some data on a parent scope, and all the children kind of go in and access that, change it at will. And we also do it by mutating that state. So everyone is kind of free to change objects and arrays. And over time, you sort of have this problem that you lose the ability to figure out what's going on in your application, because you have some code that you wrote last year that is changing the data you're dealing with today, and you can't remember where it was, and things keep changing. And the problems with scope soup are the kind of problems that components really solve, or at least make a lot easier to deal with. And that's why I think it's a good idea to try to go for components, even if you don't plan to port your app into Angular 2, because it just improves Angular 1 code, period. So what I've been doing in the past few months is essentially changing an application that was heavily scope soup into components. And from that work, I've sort of collected this kind of refactorings that I think apply to many applications out there, and that's what I want to spend the rest of my time today talking about. So we have this problem where we have a scope soup application, and we want a component application. So how do we go from one to the next? Because it's like a big question, changing the whole architecture of an application. And we could of course rewrite the application, but I think most people don't have the chance to do that. We don't have 2 months of time to refactor or change our application, and it's a hard sell to tell that to business. I don't think they should go with that, to be honest. And what I would suggest we do instead is use this technique that is not a new invention of refactoring code, like not any old changing of code, but actually refactoring in the sense that was in the Martin Fowler book originally, where he defined what refactoring is. How many people actually have read this book? So maybe 1 in 5. Okay, that's interesting. It's an old book, so I can understand why many people haven't read it. But I think most people are familiar with the kind of concept of refactoring. We use it kind of freely to mean any time we go and change some code. But there is like a stricter definition of this word, which is making small, simple, systematic changes to code over time while retaining its functionality. So we take this path from one architecture to the next. We divide it into little tiny steps that we do over an extended period of time, so that at each step we don't break the application. So we very strictly do one step, and then we make sure it still works. And we don't go into this whole refactoring project that takes a long time. And we don't make like a separate refactoring branch where we do all this work, but we make this part of our daily workflow. And that is what I've been doing for this application, and that is what I'm trying to share today on some of those patterns that I've been using. And these patterns are, I should say, very much still a work in progress. It's all pretty much from one application. There are some that are not. So if your application is very, very different from mine, you might have a different experience. But I do have a feeling that these are fairly universal, and you can probably apply them to many different kinds of apps. And if you have kind of other experiences, I would love to hear from you after the talks tonight, how how your applications look like and how these might apply to your code. But these patterns, I've roughly divided them into 3 groups. Well, 2 groups. There's one sort of prerequisite and 2 groups. First of which has to do with creation of components. So how do you actually introduce components into your code? And the second one is about when you actually then have these components, how do you manage the data flow between them? How does data get shared between the different parts of your UI? But the prerequisite here is to use controller aliasing, which I think most people are familiar with, which is just the pattern of putting data on scope so that you don't put it on directly the scope object, but you put it on the controller object. And then in your template, you define things so that your controller actually goes on the scope with an alias. And this just makes it a lot more easy to see where data comes from. When you have nested controllers and templates, you can see from these expressions which controller owns each piece of data on each function. And you need to do this before going into components, because otherwise you'll be spending all your time essentially trying to figure out where the data is. So this is a good idea to do whatever you do next. But then to actually start to introduce those components, there are a few refactorings that basically I've used to introduce components into a code base that didn't have any components before. And the first one, and the most obvious really of those, is to find ng includes in your templates. Because usually when you have an ng include, that really means that you probably have at some point decided that this is a separate part of the UI and I want to put it in a different file. And that's a pretty good clue that it's actually a component. So what you can do now is take those ng includes and replace them with these things called component directives. So, for example, if you have somewhere in your templates a div that has an ng include that is pulling in some template, what you can do is create a new directive whose name is somehow based on the template name. The directive has an inherited scope, and it uses that same template that you were ng including earlier. You put that somewhere in your code, and you put the template next to it so that they are in the same place and have the same name, this new directive and the old template. And then you just go and replace the ng include with an instance of that template or that component. And what's really important about this is that we've done this little change. We have something that's a little bit closer to a component, but we haven't broken anything. This doesn't actually change how the application behaves, because this directive does pretty much what ng include does, which is to create a new inherited scope, pull in this template, populate the contents of the element with that template. We just have it in this component form instead. And then what often follows from this refactoring is that quite often when you include a template, it seems to be that at the very top of that template, there's an ng controller, because templates often come with their own controllers. It just seems to happen a lot in the wild. So what you can do with these things, when you have a template that's now in this component and has an ng controller at the very top, you can take that controller from there and adopt it in that new component directive. You just make that existing controller the controller of that directive, and you use the same alias that you were using in the ng controller. And then you also move that controller next to the directive and the template, and you end up with something that's again a little bit closer to a component, and you can get rid of that ng controller. These things are now together, the controller, the directive, and the template. That's kind of starting to resemble even more what I defined components as earlier. And another way you can get to a similar place is when you have these ng controllers that aren't at the top of the template. I find that usually when you have ng controllers in the middle of some template, that also often means that what you really need is a component. So at some point you've decided that this part of the UI needs its own controller to manage it. And that is like a component already, so you can quite easily often also take an ng controller that's just somewhere and put in a component instead. So let's say we have in a template somewhere an ng controller, and inside it has some elements. And so what you do is similar thing as we did before, which is to create a new directive that has an inherited scope and references that controller that was in the ng controller and uses the same alias. And again, we put those together, so we have a new directive and an existing controller. They are now a pair. And then we replace that element with the ng controller with this new component element. And again, we haven't broken anything. We just have this new thing that resembles a component. But at this point, it's kind of usual to get into this kind of weird state that is exemplified here, which is that we have some HTML and expressions here which actually are using this controller that was previously the ng controller, but is now the controller of foobar. But you can't see from this template that that's actually the case. So it looks a bit strange because we are using a controller alias that isn't visible in the template because it's in that component. So what follows from that is usually that these inner elements from inside this are actually something that should go into the component template. So this markup that used to be nested in that big template, you create a new so this part of the markup, you create a new template for it that goes with that new component. And you reference that in the directive, and you move that part of the UI in there. And what's left in the original template is an empty element. So it's often when you end up from an ng controller to a component that what used to be inside the ng controller in the HTML should actually also go into the component template. And that's another route by which you end up in a component which has all these three parts, a template and a controller and the directive definition. And there's one more, creation, refactoring, I want to talk about, which is to just wrap some markup that exists into a component directive, which means that sometimes you don't have an ng controller or an ng include, but you just have a big template and you decide that part of it needs to be extracted out. So you might have a situation where you have this UL tag as part of some larger template somewhere, and you decide that it's really an independent part of the UI. And earlier you might have used an ng include in this case to extract the template. But you don't need to do that if you just create a component for this as well. So you can go ahead and create some component directory where you put a directive and a template. Both of these are new files. And in that directive, you come up with a good name for it. You make it have a new scope, and you make it reference that new template. And then you just copy and paste that HTML from the original template to the new template and replace it in the original template with an instance of that component. So just simply extracting some HTML from one place to another can be done in this way. And in this case, we don't need an ng controller for this component because there wasn't one before, but now we have a place where we can easily introduce one later. If foobar list at some point ends up as being something that benefits from having its own controller, it can easily have one because you can just add one to the directive then. And with those kinds of refactorings, I've been essentially reorganizing code from scope soup to components. And what ends up happening is that you get a lot of structure into your code on a file system level. So you end up getting these directories which has these three files each and it's easy to find which template goes with which controller and vice versa because they are located in the same place and they have the same name. And in general, the structure of the app becomes a lot more apparent. But what we haven't done yet is changed in any way how the data is shared here. We still have all these inherited scopes and all that problem area that I talked about earlier is still here because we haven't changed that. And when doing this refactoring, I think it's actually important that we are able to do that. So we can do one step first and then the second. We can do this file organization first and then start to look at the data. So we don't have to do it all at once, which is an important part of what refactoring is all about. But Now that you have some components, you can start to look at what they're actually accessing. And I think the most important refactoring in this case is to look at external references that the component code is making and replacing those references with bound inputs. So by example, what I mean here is that if you have a component with a template like this, there are some expressions in that template referencing something that's not owned by the component. So main controller here is something that's on a parent scope somewhere, which the component does not internally have any business accessing, because now if you try to use this component, you have to know that you have to set up this magic main controller on an upper scope. And that's not how components should work. So we should break these dependencies, and we can do it one by one. So we choose the first one of these external references, which is in this case main controller is foobar visible, a method call to a parent controller that's controlling whether this element is visible or not. And what I do with this is go to the component directive and introduce a binding for this. So we use this bind to controller to make bindings and make one called visible. And we're now saying this component has one input, which is called visible. And notice that I'm keeping the scope true definition here, which means that this is not an isolate scope directive, not yet. Because in Angular 1.4 we can actually do this combination of using a regular inherited scope combined with these bindings. It wasn't possible before, but it's possible now. And it allows us to do these refactorings one by one. So we have 10 external references inside the component. We can start fixing them one by one by introducing these bindings without breaking the rest of the code. So here's the first one, called visible. And we have to then plug that in when we use the component. So in the parent scope, the main controller is actually available, and we can plug in that original expression there. But inside the template, we just use the binding, which is controller.visible, and we no longer have a reference to the external world in this case. And then we go find the next one, which is called main controller get language in this case. We introduce another binding for that, plug in that as well at the interface boundary, and then reference the binding from inside. So now what's inside the component no longer has any references to what's going on outside. We define that all at the interface. But not all of these things are going to be inputs, because components also have outputs, because they produce actions that change the world, and those we should also break and replace with bindings. But in this case, we can use something called bound outputs. And the example that communicates this best, I think, is when you have an ng-click or some other event directive, like in here. We have an ng-click which is calling a method again on a parent controller, which shouldn't be here. So what we can do is, for these cases, introduce bound outputs. And we again go to the interface boundary. We say that this component actually has an output called onDelete, which is an expression binding. And this says that this component sometimes wants to delete this thing. And when you use the component, you have to provide the functionality for that. And we can do that when we use the component. So we say onDelete, this component, in this case, calls this method on the main controller. But inside, we no longer know what happens on delete. We just call that binding. And these two refactorings is something you basically have to repeat for as many times as you find things inside the component that's reading or writing something that's outside. And they're not only in the templates. You might find this also in the controllers. So you may have in a controller scope access, basically, scope.main controller or something. Quite common to have those. And they should be replaced exactly the same as the ones in the template. So whether it's in the controller or the template, if it's referencing something that's inherited on the scope, it should be replaced with a binding instead. And once you've done that for everything, you can kind of take the last step of making this a proper component, which is to isolate it by taking this scope true that we had over there and replacing that with an isolate scope. So here's where we say that now it's no longer possible for any code inside this component to access scope data from outside. So when you want to use this component, all you need to do is look at these bindings here, because these are the things that you have to provide for the component when you use it. There's no like extra stuff outside that you need to also know about. And that's like a huge thing for reusability and a crucial last step for componentizing the code. And if you've done all the previous refactorings, at this point nothing will break because there's no external access. But if you've missed something, it will break, and there's some of those previous refactorings still to do. And this finally is something you can, I think, with a clear conscience call a proper component. But there's still one more refactoring I want to share, which has to do with maybe some of the more difficult problems we have with our code, which is that it's not always that simple that you always just have these simple accesses to data which you read or write, because you may have inputs which you mutate. And this is actually quite common in all the apps I've seen, which is to have shared mutable state. And I think there's a pattern that can often be used to fix this issue, to make it more clear what's going on, which is to replace those with bound outputs. So I'm going to approach this too with an example. So here we have a component that looks to be like a proper component which has an isolate scope, it has a controller, it has one input which is called foo_bars, which is some sort of collection that it takes as an argument, and it has a template. And when you use that component, you just provide the collection of foo_bars that the thing will show. And inside the components template, there's an ng-repeat, which repeats over that collection, shows some information about each of those items, and also renders a delete button for each item. And on the click, that delete button will call this internal component controller method called delete foo_bar. And if we look at how that method is implemented in the controller, we see that it actually goes in and removes an item from the array. And here's the problem. So this component is mutating this array it was given as an input. And this is like a hugely common way to get things done in Angular and in other frameworks as well, because it's so easy. Because we don't have to talk to any other services or components. We have this array, we can remove stuff from it. And we do the same when we set attributes on objects or remove attributes or add things to collections or whatever change we make. This is the kind of easiest way to do it, and we do it because of that. And that's where you kind of, the easiness is kind of bad, because it takes you on a path which destroys your ability to figure out what's going on in the app over time. Because these things are not apparent from outside the component, for example. You can't know if this component is going to do some mutations, which might not be even as simple as this example. It might be 5 levels deep somewhere in a component tree. So what I think we should have as a rule with these components is that no component should be allowed to mutate any data that it doesn't own. So in this case, we have this foo_bars collection, which was given as an input to the component. And I think because of that, it has no business going and changing what's inside it. What it should do instead is just call some method, some bound output that it has been given, saying that, hey, this user wants to delete this foo_bar, but I don't own the data, so I can't do it, but I'm letting you know this needs to be deleted now. And you put that in the interface boundary, which explicitly now says that this component may want to delete stuff, and when you use the component, you need to be able to handle that. And then you plug in the actual behavior as you use the component. So here, if the main controller is in fact the owner of foo_bars, it actually also has the code that changes that collection. And if you have looked at React at all, you might recognize this pattern here, which is essentially one-way data flow. So we have data going down to the component, it's not changing that data, but when actions occur, the actions are propagated up from the component to a higher level where the data owner is somewhere. And from the point of view of foo-bar list now, the collection could be immutable. So if you want to go to use some immutable data structures, this is the kind of architecture you need to have, because these components can't change things when something happens. They need to notify someone else to do that change. And this also makes you end up with a lot more code in HTML when you do this, but that code is making your existing complexity explicit. It's not adding complexity, it's just saying that there are changes happening here, and instead of doing them in place, we collect them into this higher level where we can basically see them all and know when this data actually changes. And that was the last one of those refactorings I wanted to share today. So these are the things I've been doing to one particular code base, and it's ended up in quite good results. So it's getting more healthy. There's a lot more probably of these things to find still, and I know there's a lot of technical detail in this talk, but I hope you kind of got the gist of what I'm trying to say, which is that we have these Angular 1 applications that we have been building for several years, some of them, and they are nothing like the component applications we see Angular 2 being, or even like what is being taught as kind of modern Angular architecture. But we can transform them, so there's no reason we have to rewrite that code. At least this is not the reason for that. We can find this path of doing these small changes over a long period of time, maybe several months, and do it like mixed with our other daily work. We can do one of these things per day, for example, and the code doesn't break. We commit that change, we go and do something else, and we do the next one tomorrow. And over time, as long as the team has like a common understanding of this direction to go, the code transforms to something else, which is the point of doing refactoring. But yeah, that's my talk today. So thanks for listening. Do you have any time for questions? Yeah,
some questions?
What's happened to the controller service? It's gone?
The NG controller, you mean?
Dollar controller?
That's, I think it's still there. I don't know about Angular 2, it's probably not there in Angular 2, but in 1...
If it's in 2, it's gone.
Yeah, in 2, I think controller as a concept essentially is gone. So whatever services and other things that have to do with it also won't be there. There are probably other... The controller service is essentially a service with which you can instantiate controllers, right? Yeah. So you probably have something like that for components in Angular 2. Okay. But the service itself, I think, we won't see that in Angular 2. Yeah.
Okay. Second question, if I may.
Sure.
Require is also gone?
Require, yeah, I'm not sure about that.
Yeah, sure. I was just about, he was asking if the require in the directive, if I understood it right. So requiring another directive controller, if that is gone in Angular 2, and the answer is yes.
Okay.
Yeah. I don't know if it is, but if you know, then...
I mean, the concept is a little bit different. I mean,
sure,
the components, and they don't require each other like that. I mean,
yeah, I would guess that if a one component wants to kind of make functionality available to a lower level component, you can do that with basically these bindings or these, yeah. So there's no need for a separate.
But the thing is, you bind only one, right?
Bind like one, yeah, you need to do one method at a time or one piece of data at a time, yeah. Yeah. Or, well, you can bind a whole object which is full of methods, which is kind of going against the kind of architecture, but it's JavaScript, so whatever. Any other questions?
More questions?
I think the problem with these directives is that in most applications they go through several steps. At first you have these scope soup directives.
Yeah.
Then people might end up adding way too much functionality to them as a means of encapsulation, which seems interesting at first, but is actually also problematic. And the last step is most of the time that you end up with these components. But I think they also just shift the problem at many times, because that way you end up with these really fat controllers sometimes, because all the functionality basically streams upwards and is defined in one controller which has to pass it down to each and everything, which gets also complicated when, let's say, you have component A, which includes a component B, and component B needs a function from the main controller as well, which needs to flow through component A then, which has no real need for that, apart from passing it to B. So what is the solution for this problem then? Because this is, I think, where it gets really, really complicated and in the way of reusability.
Yeah, that's a really good question. And yeah, I guess at least like one specific answer in some cases might be that if you have really some templates that have something in between that has nothing to do with it, you can transclude, because that's kind of a way to put a hole through the architecture and basically say that I'm managing these components, but they are really rendered 5 levels down. And you can do that, but of course that's not a very general way to do it. I don't have a good answer to this, but what I will say is that I think it's a good idea to look at how the React community is dealing with this stuff, because they have these problems now. Because if they're doing this, we propagate changes up, then you have this problem. We end up putting every action everywhere, like explicitly in some kind of component tree. And how one kind of useful distinction to make in these components is between so-called smart and dumb components, which they make, especially with the Redux architecture, where smart components are things that are allowed to make changes. They talk to services, they do all kinds of asynchronous communication with kind of the service layer of the app, and they don't basically have to propagate things up. But dumb components are more like the last one I showed, which don't make changes, they propagate changes up. And you have to find a balance of how many smart components and dumb components do you use, because smart components are more complicated. When you test them, you need to mock stuff and you need to kind of do all this thing, and it's not as reusable, but they don't have this problem of having to manage all those callbacks. So what some people seem to be doing, that there's one smart component per route, so that each route has a root component that knows how to talk to services, and the rest are essentially just propagating up. But we have some UIs, for example, in our app, which are quite complicated. So if we just used one smart component, we would end up having this huge problem of essentially having 50 components that do nothing but send actions up. So we use more of them. We have like maybe 10 of smart components in there. Or we don't have yet, but we aim to have. So that's kind of one way that I've been thinking about that. I don't know how well that actually answers your question, but if it doesn't, it's because I don't know.
Yeah, it's not that easy. This will be what Sebastian and I will try to talk about in that Angular Connect as well, and it's complicated. Yeah.
Right. Looking forward to hearing that.
Yeah. Also, always end up at React somehow.
Yeah, I think there's a lot of like cross-pollination between these architectures right now, and this is basically what I'm doing here. It's all from React, having these inputs and outputs and components is something that comes from there, but it's not specific to React really. It's just it's the same thing as replacing shared state with function arguments and return values in like non-UI code. It's really boils down to kind of general software design, and React gets some things right there. But it has its problems, and we I guess have to be careful not to copy those problems to Angular.
Thank you.